Okay, good afternoon, everyone. My name is Christoph Huerzeler. I'm with Alstom Power, but today I'm actually speaking for Alstom Inspection Robotics, which is a smaller independent spin-off of Alstom, which is really focusing on developing new inspection robots. What I will talk to you about today is basically focusing on aerial inspection of different power plant facilities or in general industrial facilities. And regarding the motivation, maybe you allow me to quickly give a little bit the Alstom perspective on the problem. So if we think about power plant servicing and maintenance, then often it is underestimated how valuable it is to just look at specific subsystems or components of a power plant, because this can already, just looking at a specific component and its state can give you a tremendous amount of what is going on, of information about what is going on with your power plant. Now, problems there is either the components that you're interested in are in a very confined space, so they're very hard to reach. So you need, for example, a crawling inspection robot to bring a camera into a specific structure and look at a particular component, or what you're interested in is an industrial structure that is very vast, very large scale. So, for example, it could be a typical application like a large steel chamber, basically, and at 80 meters height, there's a specific component, and you want to look at that component. Now, what you can do is shut down your power plant or part of the power plant and build scaffolds to go up there and look at the component. You can try to have an industrial climber try to get to this particular component. All of that is a lot of work, of risks, of course. So if you just had a small eye in the sky, basically, a flying camera that you can send up there quickly, and it looks at the component, takes camera images, that would be of tremendous value. Now, there are some challenges involved there. The most particular one is that basically in the infrastructures we're talking about, you have no position measurement for the aerial vehicle. So outdoors, you generally have a GPS signal, so you can localize the vehicle, and then through that, basically, you can implement certain control algorithms, which then allow you to in a very simple way, operate or fly the aerial vehicle. Indoors or in the facility components which we're focusing on, this is not available, which makes this vehicle very hard to pilot in this infrastructure. Imagine again, at 80 meters height, you just see a small black spot in the best case representing the UAV, and now you need to operate that UAV very close to a specific structure. So you need some sort of support for the operator or the pilot there, and for that you need a sensor system basically that gives you information about where is the UAV, in particular with respect to its immediate environment. Now, one big challenge there is that basically we're now operating really in complete 3D space. That means if we talk about collision avoidance or collision detections for our UAV, an obstacle in our case can come into contact with the UAV from any point or any direction. So they're basically, in the best case, there would be sort of like a virtual sphere encompassing the UAV platform, which senses if an obstacle is coming near and then prohibits the operator to move the UAV further in this direction. There's also the problem of robustness. Like if we just put one sensor on there that gives us a position, for example, what happens if this sensor fails? Then we're back to the problem of we have nothing that supports the operator operating the UAV, and we will probably crash the UAV immediately, which is also a problem because then basically we interrupted the plant operation for servicing, and now our servicing tool broke, and we need to repair it or get a new tool, which is time we lose, which we might not want to lose. Now, coming to more to the challenge itself, basically what is provided to the challengers as a platform, as tools, which they work with. The core idea here is really they shouldn't focus on just making something fly, because we consider that a solved problem. So what they will basically get is a flying platform, a small flying platform from a German company, Ascending Technologies. Roughly this form factor, this size, which means it's rather safe for the challengers to use, and later on in an industrial application, again, it's safe for a human operator to work with this vehicle. Additional, there will be at least one sensor, a stereo camera, which is sort of targeted at the UAV application per se. But then in the background, the idea is really that the challengers add other types of sensors for the robustness, and then really work on the algorithmic part, using the sensor data to localize the vehicle with respect to the environment. There, of course, will also be an SDK to interact with all, or SDKs, to interact with all of this hardware and the software simulator. In terms of support, the challenge hosts will be two laboratories, two departments at ETH Zurich in Switzerland, one of which is the Autonomous Systems Lab, and the other one, the Institute of Dynamic Systems and Control. And both of these departments, both of these laboratories already have a tremendous amount, years of experience dealing with these types of platforms, of vehicles, and the problem itself of controlling these vehicles also in challenging environments. So there will be plenty of experience and support there. Then we have, of course, the technology developer, Ascending Technologies, which provide the platforms and also support dealing with the platforms. And there's the system integrator, Alstom Inspection Robotics, which will basically support the challengers to focus on the correct problems, like what are the parameters or challenges in terms of environment that they should focus on. As contact points, we have Markus Achtelik from the Autonomous Systems Lab, ETH Zurich. We have Daniel Gurdan from Ascending Technologies, and Eckhard Zwicker, who unfortunately couldn't be here today, from Alstom Inspection Robotics.